We'll just jump right into it.
Okay.
I'll start question 3. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25. So for this, we're just going to go to the applet and type in 0.9 for the area. That gives us a z-score of 1.645. And then we just solve for the margin of error by taking 1.645 times the standard deviation, which is 50, divided by the square root of n, which would be 5. So 50 divided by 5 is 10, times 1.645 is 16.450, because they want 3 decimal places.
That's what I got.
Perfect.
All right. Let's see, which of the following statements is true? I think it's the sample mean is a point estimator of the mean.
Yep.
Yeah.
That's what I got.
Alrighty.
Okay. So we're going to use this information. Gina wants to construct a 95% confidence interval for the GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size 64 and computes the sample mean to be 526. What is the point estimate for the true GMAT score? That would be the sample mean of 526.
Yep. All right. So number 6. What is the margin of error for the 95% confidence interval for the true GMAT score? Let's see, number 6. So that was, so we're doing 95%, and that is 1.96. So we do 1.96 times, let's see, 113 divided by the square root of 64. And I got 27.685.
That's what I got.
Very good.
Yeah, I know some of these numbers I was like, I don't know. But...
I know.
Okay, number 7. What's the lower limit of this confidence interval? So we just take the sample size or sample mean of 526, subtract the margin of error, 27.685, and I got 498.315.
All right, good. That's what I got. All right, number 8. What is the upper limit of this confidence interval? So the upper limit, to get the upper limit, you do the, let's see, which one is that? So you do the plus instead of the minus.
Mm-hmm.
And that one is, so it's, yeah, so that's 526 plus 1.96 times 113 divided by the square root of 64. And I got 553.685.
Mm-hmm.
All right.
It's just the sample mean plus the margin of error.
Yeah.
Number 9. What would happen to the width of the confidence interval if Gina increased the sample size? And it would decrease.
That's what I got.
Mm-hmm.
All right. So number 10, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval and it would increase? Because the range would increase or whatever.
Right. Yeah, the area. Number 11. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? to get that margin of error. So for this one, you're just doing the sample size equals the z-score times the standard deviation divided by the margin of error. So we're doing z-score of 1.96 times 400, which is the standard deviation, divided by 50, that's the margin of error, and you square, you square that number, and that will give you 246.
You got 246.
So we're rounding that to the
whole
number.
Glad you noticed that. I didn't round it. I had 245.862. I didn't see that.
Yeah, I got to round it to the nearest.
All right, so this one, let's see. So the mean salary of actuaries is 100,000, and the standard deviation is $36,730. You're interested in to know if the mean salary for women actuaries is different from the population mean, but you are not sure if it is higher or lower. You set up a hypothesis test with a level of significance 0.05, and let's see here. So, what is the lower limit of this 95% confidence interval? So I got this one wrong, and I'm not sure why.
That's right. So pretty much what we have to do first is we need to find the margin of error. So that's what we're going to focus on first. So it's a 95% confidence interval. So we're going to use the z-score of 1.96. We're going to multiply that by the standard deviation of 36,730.
Okay.
Divided by the square root of 36, which is the sample size.
Okay.
So it's it comes out to 11,998.
Oh, okay.
Is the margin of error. Did you get that?
Let me just plug this in real quick, and
That's fine.
Just make sure I did it right. I must have put the wrong number in somewhere.
Yeah, that's what I did.
Oh, did you?
And then I realized what I did. I just did a double number.
Yeah, I got 11,998.
Okay, so then that's the margin of error. So then we take the sample of 111,000. You subtract 11,998, and that will give you $99,002 because we're rounding it to the nearest whole number.
All right. 14. There are 3 requirements that need to be checked when.
I think we're on 13.
Oh, did I skip one?
Is it my turn? I don't remember. Yeah, I think it is. 13 is what's the upper limit? So now we just take 111,000 and you add 11,998 to get 122,998. Okay.
Yeah, here. All right. Let's see. So now 14. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are, let's see. Is it A? Is that what you got?
So it's actually all of those are required.
So it does have to be normally distributed?
Mm-hmm.
Okay.
Yep.
All right.
All 3 of those. Let's see here. Okay. Yeah, for this one, I think the only problems I had was just kind of conceptualizing the width but I think once I slowed down and like thought it through,
Mm-hmm.
like if you were to increase the level of or the confidence interval, what does that do to the margin of error or whatever? And you can kind of like go through it mathematically, but that just takes forever. So I'm kind of. But anyway.
So, all right. Well, cool.
Yeah. Do you have any other questions?
No, I think you got to figure it out for the most part. So.
All right. We'll see you on Wednesday then.
All right, man. You have a good night. We'll see you.
Yeah.